That was a very quick introduction. I thought I had 10 more seconds or something. All right, welcome. I'm going to talk about, as it says, how you can understand almost anything. And of course, this is intended, basically towards analysis, requirements, understanding a domain kind of stuff. So it's not literally anything, but I think the title is nice. It's also based on a book. I set up a discount code. I think you can get it now for whatever, $10 or something at LeanPub. So if you aren't satisfied with the talk in terms of content, then you can get more from the book. If you just hated the way I presented, you're out of luck. All right, introduction. Anybody knows what this is? Yes? Anybody wants to say? Satellite. No, not a satellite. Radio telescope, exactly. More specifically, that's a radio telescope array, right? It's a bunch of antennas that are connected in a so-called interferometer, and the ALMA array, actually, I worked on that a long time ago. So if you're an astronomer and you want to observe something, right, some, whatever, supernova going on or whatever it is, I actually don't know anything about astrophysics, you want to observe that. What you do is you open your word processor, right, Word, you open the document, and you write in plain English what you want to observe. Like you try to be precise, right, because some engineer and programmer will take your document and program the telescope to do the observation. And of course, they will misunderstand it, and so you have to update the document, and you go back and forth. It's a very tedious process. Of course, that's not what happens. Instead, what happens is that there is a way for end users, in this case physicists or astronomers or whatever you want to call them, to directly program the system, right? So they have a language, modeling tool, specification environment, name doesn't really matter, with which they can directly describe these observation procedures. And they are complicated. Like there's hundreds of parameters you have to configure, and then you sequence these things and so on. This is essentially a programming system for the telescope. So they create these configuration programs, observation scripts, whatever you want to call them. They use some kind of language for that. The language has been defined to cover the domain of radio telescopy, specifically for the ALMA telescope, right? It has been, the language has been built, the tool to configure has been built by some software folks, right? That was what I was involved in a long time ago. And they did that, of course, together with domain experts, with people who really understand how this telescope works and what you might want to observe in the sky. And of course, then there's a feedback process. So the goal of this approach is to optimize basically the chain from the subject matter expert's brain into the running system, right? And the classical approach that I kind of jokingly started with, where you essentially write some kind of requirements prose for each observation, is not what I would call an optimization of that brain to running system path. However, this is how we build almost all of our software systems in business, right? Hardly any of them are end-user programmable or subject matter configurable or whatever you want to call it, right? There's usually always some expert who understands drug trials or salary tax calculations or the rules behind tracking driving and brake times of truck drivers or all the other stuff here. They understand that and they write, I mean, it doesn't have to be a big requirements document or Lastenheft in German, right? It can also be a bunch of user stories. Doesn't matter, but it's prose, it's informal, it's not directly executable. So the subject matter expert people are one step removed from actually, quote, programming the system. Of course, they don't want to program because they're not programmers, and they are very proud of the fact they're not programmers. They do not know what a curly brace is, and so on and so on. So you, of course, have to build these end-user configuration systems in a way that is understandable by your target audience. You have to understand what that is. However, the core point is that you have this language formal language that represents the domain of laser welding systems or radio astronomy or calculation rules for the whole German tax system. This is, of course, quite related to a cornerstone of DDD. I obviously don't have to tell you guys the definition, but there is this ubiquitous language, which, as you know, is this essentially terminology / glossary / human-to-human language that you use to build your architecture system design on top of. And I think that's a great idea, except that it stops halfway, right? Why not formalize that ubiquitous language into an actual programming, modeling, specification language that you can use to directly program the system? Now, if I continue what I'm talking about in the classical way, I'll end up telling you the benefits of domain-specific languages, which is not the goal of this talk. But I still think that thinking about a domain in terms of an actual formal, by which I don't mean Greek letters, I mean executable language, is extremely helpful to understand any domain and then build any kind of software system, ideally end-user programmable, but perhaps maybe not. So there is another thing that I found on the source of all knowledge, Wikipedia, that says that critics of DDD, I didn't know they existed, but critics of DDD seem to criticize that the problem with DDD is that you have to implement a great deal of isolation and encapsulation to maintain the model as a pure and helpful construct. I find it funny that this is mentioned as a drawback, because in my opinion, separating, and by that I don't mean organizationally, but technically separating the subject matter of a system from all the technical crap and the utilities you need to run it is, in my opinion, the biggest or most important architectural decision you can make, right? And there's different ways of how you do that, but separating the model from the utilities, I think, is very useful, right? So I kind of weird how this is mentioned as a critical or negative point, but what I'm trying to say here is that the representing the behavior of a particular observation, text calculation, laser welding control thing as an executable model is the best way of separating it from the technical stuff. And of course, you then have a code generator or some interpreter to run it, right? Anyway, so the point is, if you want to use this approach, and you should use it more, in my opinion, if you want to use this approach, where does this language come from? How do you understand deeply that domain for which you want to build your formal ubiquitous language, if you will? There's a lot of stuff involved here. You have to obviously understand the domain, you have to design the language, you have to implement some kind of programming / configuration tool, you have to architect the software system in a way that it can run the models while still maintaining all the utilities. You have to then build runtimes and or generators to transform your model into actually running code. And you have to, biggest challenge, introduce all of this to the organization, which might not necessarily initially understand why you want to do this. So lots of stuff to do. What I want to talk about today is understanding the domain. In other words, domain analysis, which is what the book is about and also this talk. So let me check the time, 10 minutes, okay. Click. So what is domain analysis? First, we have to define what a domain is, right? And it's one of these not very useful definitions because it just says it's something with a boundary. So a domain is an area of interest and expertise. That is important, right? Expertise. You identify domain experts by their actual experience in a domain, often owned by a particular organization. Like, for example, you could argue that, I don't know, tax law is a domain, but if you are DATEV, a German tax calculation software service provider, then they might have certain interpretations of that law or certain ways they deal with it in the organization. So the domain is not just tax law in general, but tax law in the spirit of DATEV, right? So that's why I mean by this owned by a particular organization. There are usually people who are experts in that field, in that domain. They understand large parts of the subject matter. And by that, I don't necessarily mean that, to stay with the tax law example, that they understand every one of the, I don't know, 5 million tax rules in Germany. Maybe it's only just 10,000, I have no idea. too many. But they understand the structures behind it, right? They understand how you describe these text calculation rules and how many exceptions there are, and are there exceptions, and which things are regular, which are just a bunch of exceptions. And then usually these people are old because they've been in the organization forever. And I've been in more than one project where the main reason for building this, understanding the domain, was that the guy would retire in 2 years, right? Actually, my first project in that space was in the Netherlands, and the guy was called Herman, and he was 63, and it was obvious what we were doing there, right? We were basically dumping his brain into a piece of software so that he could leave. So, yeah, I mean, it was an insurance in this case. It was not tax, but anyway. So domain analysis is about capturing this subject matter and the rules behind it outside the brain to make it accessible to a wider range of people and, importantly, to software tools, right? It's not enough to analyze the domain to the degree you can teach it to your fellow colleagues, but rather you want to become so formal in your, quote, language definition, in the understanding of the domain, that you can build a tool that when you create programs or models with it, you can actually run it. So when I say accessible to software tools, it means you have to identify the data structures, constraints, rules, semantics, and the ways to describe them, right? And in the end, you essentially build languages. Again, I don't want to spend a lot of time defining what I mean by language. I did that in my hands-on lab yesterday, and it's also usually a point of discussion that is fun but not helpful. So the point is, it's formal enough to execute, right? And so then, once you have this language and the underlying data structures and meta models, I said the meta word, defined, then you can generate/build APIs, software structures, checkers, compilers, UIs, transport protocols on top of those. But you have this one model that is your formal truth, right? And then again, how far you automate the construction of the rest of the system is not the point of this talk. Right, I don't know why this is here again. So, in terms of domain analysis, I have, as I said, I wrote this book, and it's basically a distillation of a couple of years' worth of, unfortunately, not programming, but just doing the analysis part of things. I found a way to program nonetheless. I'll get back to that towards the end of the talk. And after lots of hard thinking, I came up with this main structure to analyze something. And of course, obviously, at that point, it's completely non-surprising. That's why I'm kind of talking about it this way. You first have to collect information about the domain. Then you have to think hard about it to find the right abstractions. And then you have to validate it. Again, this is basically just a way to structure the rest. It's not rocket science to come up with this structure. Importantly, you want to iterate about this. It's not a good idea to, I don't know, it's the word Elfenbeinturm, something that works in Dutch, ivory tower, right? You don't want to put yourself into a little room at the end of the long corridor in a company with the domain expert and not leave the room for half a year to come up with the language. Probably won't work, right? So you want to do this iteratively. And in my work, I usually run one of these cycles within a day or two, right? Collecting in the morning, thinking in the afternoon, validating the next morning. Typically, right? Just to give you a feeling. Anyway, so the rest of the talk is basically a bunch of practices, thoughts, experience regarding these three things, right? So, collecting. First thing is there's different ways or different sources where you can collect. By the way, that was when the AI image generators were kind of new. I created these slides a couple of months ago, so strange pictures in there. So you can either grab knowledge from people, documents, or previously written code in legacy systems. In my experience, documents aren't a great source. They're usually outdated. They are often imprecise because prose text is imprecise, which was our starting point. They're usually not written with a lot of love, which makes them not very fun to read. And maybe more fundamentally, similar to the being outdated, they often represent the status quo. And usually when you run a domain analysis, you don't want to just exactly replicate the way you have been doing it the last 30 years. You want to get rid of old crap. You want to, refactor your understanding of tax law, make it a little bit updated. Maybe some parts of your business model changes, right? For example, DATEV, they have been thinking a lot about the fact that the actual tax calculation itself, where you enter all the data as an end user and then it tells you how much you have to pay, is not so interesting in the future because that will be done, worst case, in their perspective, by software provided by the government directly, right? So they're out of business. So they have to provide value-added services around that. And so the question is, how does the understanding of the domain have to evolve to facilitate that? Biggest challenge was, what are those? Nobody knew. But anyway, so documents, to the extent they exist, they describe the status quo and not where you want to go in terms of the domain. You can also look at code, perhaps. Same problem, right? Status quo. It's also usually very low level, so it's very hard from the code to figure out the actual domain level, how things work. I mean, that's the reason why you want these models, as opposed to baking everything into low-level Java code. Right? So traditionally, people don't have formal languages and separations of entities from subject matter. So if you try to get your information from the code, you are digging in the mud. So people, right? It's people you want to get your information from. And the reason why I say that is because in many projects, when I arrived there as the guy who kind of runs the domain analysis, I said, here's a bunch of documents, read them, and you'll understand. Of course, you won't. And so telling them, no, keep your documents. Okay, I'll read them about an hour so I know the most important terms. But then I want to talk to people. But they have no time. Okay. Anyway, the way I usually structure these teams from which I can get the information, I call this the analysis team. There is the analyst, right? That's in the, usually, in the projects I'm participating, that's me, right? I'm the guy who tries to abstract things into a language. There's the domain expert, that's Hermann, right? Who knows everything. And there's what I call the core group. It's 4 or 5 future users, reasonably senior people in the domain, maybe also 1 or 2 new ones to get the whole breadth of experience. And I basically work with them all the time. There is the future users, right? These are at DATEV, dozens and dozens of people who will use this language to implement all of German tax law. There's other stakeholders, for example, software architects, who understand, for example, which external data needs to be involved and in which format this arrives. It's obviously not directly related to tax law, but it's very important in terms of how you design the interfaces that your code language needs to work with. And then there's, of course, management, as always. Ideally, they don't get involved with the other stuff, but they set scope, prioritization, and are involved in decisions that affect business. When I said earlier that you want to refactor the business model and the way the domain works, they are involved there, of course. Usually they don't have time to be involved, but they make decisions anyway. A very important point in a domain analysis is an agreed terminology. And again, this is a trivial statement, but there's 2 things that are not trivial about it. One is, sometimes people think it's enough to have a glossary and you're done, right? That is not the case. I don't think, again, my mindset, always having a bit domain-specific language in the back of my mind, a list of words with prose definitions isn't enough. It's not formal. I can't run it. But if you don't have consistent terminology, everything else will be futile. We have had projects where there was an officially defined term session, and there was another officially defined term, patient session. That was in the context of drug trial software. Guess how everybody shortened the word patient session? Session. At which point it was completely overlapping with that other term. And we had, I'm not joking, hours of misunderstanding because people used the wrong session term. And so, it's stupid, right? Don't do it. So, the main means of extracting that information from your core analysis team's brains is through workshops or meetings or whatever you want to call them. And of course, you as the analyst usually have to run them. And so one thing you have to do is the basics of moderation, right? Make sure there's breaks, allow everyone to speak, make sure nobody dominates, have an agenda, steer towards conclusions and not just blabbering, right? Capture the results, stop strawman and sabotage. So, I mean, that's the basics of running every meeting, right? You have to do that as the person who runs it. Not gonna talk about this more. There's more you have to do as the analyst in these meetings, and that's actually quite a bit more challenging. I call it steering the analysis, right? First of all, sometimes disagreements between different people are very helpful because they uncover something that's not clear that needs to be resolved, right? So if you are a classic moderator, and I had this in some of these meetings at one of my customers, and people start somewhere between disagreeing and shouting at each other, right? Your reflex is to shut it down because we're all friends, we can't disagree, we can't shout at each other. And of course that's fine, but sometimes you have to let people fight it out for 15 minutes so that you can get to the core of the issue. And so distinguishing good and bad quarrels is really crucial, and deciding which of them you let run for 15 minutes while you have a coffee and watch, and others you stop because they become personal and are really not helpful, or just revisit the discussion you had in the last meeting and already made a decision. You have to, and that's something I'm really bad at because I like to dig into those as well. You have to identify rabbit holes where people fall down and are unable to come back out, right? In my current project about these laser welding machines, there is one guy on the team who has a very much mathematical background. And whenever we say something about how we describe certain geometric shapes, like you want to weld a circle or a line, he starts with a mathematical diatribe about how to describe a line in a way that's precise and can be oriented in 3D space and blah. Nobody gets it. And especially none of the users will get it, right? So like every time he falls down into this rabbit hole and doesn't find his way back out. You have to help such people, right? You have to make sure you don't get stuck in dead ends that really aren't relevant. And this really aren't relevant is, of course, the key word, right? You have to be able to identify when it becomes too obscure, too flexible, too abstract, too mathematical in this particular case for it to be useful. And then your core job is you have to build a mental model of how the domain works, right? What are the right abstractions to describe these geometric shapes you might want to weld? Or what are good ways of describing, what is a good language for describing tax rules? And I'll come back to that later, but you have to try to detect holes and inconsistencies in what people tell you, right? You build this mental model, and if somebody tells you a requirement that contradicts other stuff you've talked about before, you have to detect this, right? And that's hard, and you need tools to do that, and I'll get back to that later. You have to verify the right abstraction level. Again, this was this mathematical example. If you're too low level with three-dimensional planes that intersect, blah, then it's probably not the right way for people who want to just weld a bunch of metal together. You typically, when you are told something, it's a good idea to give a counterexample as a way, if I do it, if we build the language in the way you just explained I should, then we cannot express the following. Is this correct? Like you challenge people by giving counterexamples. It's extremely helpful if you can come up with them. And of course, you encourage others to give examples, again, to get the breadth of experience. And another very important thing that is, I don't even know why, but it's really something that often goes wrong. So you agree on something, right? So there's a room of 6 people. You discuss something. After half an hour of discussing, you agree on something. You write down, we just agreed on X. You continue talking about somebody else, about something else, and 10 minutes later, somebody contradicts X. Now, you could argue, okay, they were asleep or they're malicious, but that's not my point here. Sometimes people are asleep, different problem. It's that it's very hard to phrase and write down and just ensure a common understanding of what we actually just decided. Like, what is it that we agree on? How far does the agreement go? What's the scope? What is outside? What are counterexamples again? So when you write down, we just agree on something, like somebody takes notes, right? So we just agreed on always assuming a two-dimensional description of our geometries in the welding application. Okay, fine. What does this mean? Can I move my laser up and down to change the beam width? Is this three-dimensional? Who knows, right? You have to say these things. And you can be a step better than saying. I'll get back to that. So again, agreeing on what we just agreed on is really tough. And you also, I needed to, fit in some less AI pictures. You also have to be willing to tear down the model, right? You just spent 45 minutes building this nice mental model as people told you stuff, how the domain works, and now somebody comes up with something that just doesn't fit. Now, one thing you can do is to say, okay, you're wrong, go away. I just want to keep my nice mental model. And sometimes that's the right thing. If it's a strange, stupid corner case that you don't want to support in the future because it breaks everything else, then it's the right thing to shut this idea down. But more often than not, especially in the early phases of these kinds of analyses, it's a good point. And yeah, you have different abstractions. So the last 45 minutes are canned, and you have to start again, come up with a different mental model. And you have to be willing to do that as the guy who, quote, owns the model. Often people don't. They fall in love with their great abstractions, and everything else is then, of course, wrong. So another thing I encourage you guys to do in these kinds of situations is active listening. It's not something I invented. It's a well-established term. So if somebody tells you something, re-explain it in your own words, right? State explicitly what you think they didn't mean. It's, again, the counterexample thing. And then, importantly, rephrase what they just said in terms of the abstractions/language we have designed or agreed upon so far, right? You try to express it within the set of stuff you've already agreed on, and that helps either, identifying holes in what you agreed on, or pointing out that the guy is wrong because they just expressed something that doesn't fit with the system. And so you point out whenever a speaker makes implicit assumptions about those, when they're imprecise in terms of the domain language you've uncovered so far, when they contradict previous agreements, and also very important when they mix different aspects of the problem. One thing that happens, especially if you talk to software people, like, you talk about data structures, and then, yeah, but in XML, we can't do this. I said, hey, we don't care about XML. We're just trying to understand the structures. Don't mix technology with domain, right? And so identifying when stuff that shouldn't be mixed is mixed is important. Now, there is a bunch of caveats. One is that you have to make sure you don't appear arrogant. If you're the guy who understands everything because you're the great model person, and whenever somebody says something that doesn't fit you, oh, you're wrong, right? Doesn't build a great atmosphere. I'm sometimes a bit like that, and wasn't not always good. So one thing you can do, like, without changing your character, right? I can be aggressive in that sense sometimes, but you can always acknowledge before you criticize. You can say, okay, I understand what you said, and I think this part makes sense. It fits with the rest of the system in the following way, but I think here you said something that doesn't quite fit, right? First, acknowledge the probably 80% of what is consistent with the rest of what you talked about, and then you point out the 20%, quote, wrong, instead of just saying, yeah, but I think that part is wrong, right? The other thing is that, at least in the context I'm usually working in, I'm the person who has the most experience with this language meta-level abstraction stuff. That's why they hire me, right? So it's very easy to overwhelm the rest of the team with fancy abstractions and a meta-level that contains another meta-level to describe the meta-level that lets you describe the domain. Even if it's not, in the end, not visible to end users, your buddies in the analysis team probably won't be able to follow, at least not at the speed you might be able to explain it. So be careful about that. And again, you need somebody on the team who is willing to tell you, hey, slow down, Mr. Analysis guru, right? And because you probably won't notice, because everybody will just shut up and say, yes, expert, we believe you. That's not great, right? If you don't get good feedback and if people don't shoot you down, then you make the wrong abstractions and the wrong language, and then nobody wins. So, another thing, consistency versus change. So what you don't want is that as time evolves in your analysis, that everybody has a slightly different understanding of what they think the language is, the language you've defined so far. What you want is instead this, where in regular intervals you kind of collect everybody together on the same page, which is, again, one of these obvious statements, but it's hard because some people are missing in certain meetings, they read something and interpret the wrong way, they have a different background, right? So it's very easy to diverge, and then after spending 3 months analyzing something, you notice at the end that you don't know anything, right? Everybody has a different understanding of what you claim to have analyzed. So, and I'll again get back to this later, how I think you should avoid this. But so far, just be aware of it and make sure this doesn't happen. The other thing is that you have to put uncertainty into a box. What I mean by that is if you get to a point where you cannot make a decision whether something should be red, green, or blue in your domain, right? Then it's very easy for people to become like generally frustrated. Oh, okay, now we don't know how the color works, and so then this doesn't work, and then everything kind of breaks, and what are we doing here, right? That's very frustrating and not very helpful. So you have to make sure that you are able to specifically describe what the problem is and what the alternatives are you aren't sure about. Like, it's not 16 million colors, it's just red, green, or blue. So you've already made some progress, right, in terms of narrowing it down to 3 alternatives. And then you have to say which adjacent or related issues are certain. What can we agree on? That's kind of this box that I'm trying to put the uncertainty in. Like making sure that the uncontrollability, the unknown doesn't like spread into like everything and everybody's just frustrated, but you describe precisely what's unknown, what's unclear, what are the alternatives, and again, explicitly say, but we agree about that part and that adjacent thing. So that's kind of the constraints within which we know we have to agree on what the solution is that's currently unclear. Right? This is very important. Again, kind of a psychological thing, but it really helps to be clear about this. Now, you have to, in your collection phase, capture results, obviously. And I suggest you use an issue tracker for that, not a wiki, which is going to be a garbage dump after 3 months, in my opinion. It's very hard to keep it structured. Same is true for Word documents. Also, issues can easily be identified, commented, prioritized, searched, right? So you get notified if they change. I like an issue tracker to just capture these decisions. So what you put there is you put the decisions and the rationale, brief one, scope, counterexamples, the open issues around it, and potential disagreements to revisit it. It's a bit like architecture decision records, right? But you do it for your domain language, for the analysis you try to run. Very important. Keep the amount of stuff you put there brief and keep it pragmatic. If you have a 10-section issue template that you have to fill in for every decision you've made, nobody will do it, and it'll just die, right? It's something, in my opinion, that you have to keep in mind for any kind of documentation task. If you force people to be too elaborate, it just won't happen. And so keep it pragmatic. And importantly, the thing I'm talking about here is a Teams working tool. This is not public documentation. That's something else. I'll get to that. And importantly, ban email. Do not capture decisions in email chains. I mean, it's like almost a running joke, right? Everybody, but I've seen this many times, like with 10 quotation carrots. Doesn't work. Okay, now that you've collected, you can think. First, important, make time to think. Everybody's calendar is completely full. It's funny how developers, it's accepted if a developer doesn't have 100% of their schedule filled with meetings, because everybody understands at some point they have to write some code, right? But for people who are supposed to understand things and design and understand the domain and decide, it's completely fine for them to be completely buried. They don't need to think, right? Which is weird. So make time. The other thing is, be very clear about the bounds of the domain. Like when we did something in this tax environment, we were talking about, do we only do business to consumer, also business to business? Or same, for example, in insurance companies, business to, and consumer insurance works differently than business to business kind of large-scale insurance. And so understanding where you set the domain's boundaries is important, because otherwise you probably won't be able to find good abstractions. That is also a little bit kind of the bounded context idea, right? Do you have one domain? Do you have multiple domains? How do they intersect or interrelate? And where do you set the boundaries so you can have nice abstractions for the domain inside the box, right? Instead of every box influencing every other box. You have to identify, question, and remove cruft. Cruft, by that I mean old stuff, historic accidents, pragmatic shortcuts. Like back then we had to simplify things because otherwise the system was too slow, you know, when we 386 computers and stuff. Special solutions for, worst case, former customers. So you have this nice abstraction, but all this other exceptional crap for a customer you no longer work with, right? Not good. Hacks to get things more faster, yeah. Changes in business strategy and priorities, right? So identify these, and then hopefully decide to kill them. Problem is with identifying, it's usually not written as in the code, you know, if custom of special flag then. If it's like that, then it's nice, easy to identify. But it's very funny how in an organization, strange stuff that you've always done in a certain way is considered gospel, and it has to be that way. And if you question it, it's very hard to identify which parts of that gospel really make sense and which is hidden cruft. And you, as the kind of external or charged to be the guy who understands the domain, you have to point these things out. Nobody else will. Yeah, and then you have to find the right abstractions, which is funny because that's the core activity, and I can say the least about it because you just have to be good and find the right abstractions. No, I'm serious, it's very hard to say, how do you find the right abstractions, right? I mean, I spent 37 minutes talking about techniques to find out the information, the domain structure that you want to abstract. But what is the right abstraction? The only thing I can say is usually there is a trade-off between expressive power, like how flexible do you want to be in expressing things in the domain, how powerful is your language, versus how easy is it to learn. The more powerful, the harder it is to learn. And problem is that many of your users, future users, when you give them the prototypes for feedback, they are in the learning phase. So they will give you feedback about learnability, usually, not feedback about to what degree the language is suitable for actually solving the challenges in your domain. So that's a hard thing to do. And so the only thing I can tell you, I say a bit more in the book, but basically you have to just keep that in mind and make that trade-off explicit. You can say, yeah, I understand that this is complicated now, but you just told me in the last 3 months that you have to solve these problems and you need that language to do it. Okay? And then genericity versus specificity. Anybody ever used Lisp? It has 3 language concepts, atoms, lists, and functions, lambdas, maybe 5. I don't actually ever use it. And anybody ever used ABAP? Okay. Mein Beileid, what's it in English? Anyway, so there you have 387 keywords. There's a keyword for everything. There's a clearly different style of language design, right? And don't mix it. It's going to be ugly. And more importantly, you have to really make decisions how, to what degree you want to allow your future users to build their own abstractions in the domain. Like, again, Lisp, it's obviously not a domain-specific thing, but it's a good comparison. In Lisp, it gives you like 5 things that are extremely composable, and you can build your own world from scratch, grow the language bottom up. Whereas in ABAP, you can probably define your own, I mean, sure you can define procedures and classes and stuff, but there's lots of predefined stuff that is used to guide you in the business domain, right? And the ABAP is certainly not built to build your own frameworks. I'm perhaps wrong, right? So the corner up there who has used it, don't don't judge me. But this is another trade-off you have to make. And again, blah. So 2 more things you want to explicitly keep. I'm running out of time, so I'm speeding up a little bit. You have to identify which parts of the domain never ever change, so you don't even have to describe them in your models. You just put them into the platform. And which things are cross-cutting and affect everything. For example, in the text environment, something that affected everything was time-based data, like monthly salaries, yearly taxes, right? Or monthly taxes, value-added tax. Germany is monthly, for example. So building support for these time series, time-anchored data into the language at the very foundation in a cross-cutting way that affects kind of everything is important to figure out. I'll skip that. Validation. 2 key things you want to do to validate that your understanding of the domain and the thinking results you created are valid. One is write. Write them down. Write them in a way that is precise, because that helps you find inconsistencies. And please, don't write on PowerPoints. Now, this might sound like a stupidly specific thing, but PowerPoint and the alternatives idiomatically kind of make you write bullet point lists. And the point about bullet points is that usually you don't connect them. The reasons why and the kind of semantic connections between things are missing. You just write, I do this, and then I do that, and then that's an abstraction, this is another one. Full stop. I said it, right? But it doesn't explain how it fits together. It's awful to read, right? Especially if it's not presented, when it's intended as a slide you meant, right? It's really a bad thing. So just consider it literature, or a book, or if you will, a paper without 5 million references and Greek letters. So it should be able to be read on the subway. It should be, I'm not saying it should be entertaining, okay? That goes too far. But it should be readable in a way where you're not like 2 paragraphs in and you've completely lost context of everything because it's only a bunch of bullet points and you have no idea. Or another bad thing is these highly structured documentation templates, for example, ARC42. I understand why they exist. I'm not saying they're completely bad, but I've seen so many where there was like 5 levels of indented subsections and each contained 1 sentence. It was unreadable. The context, the connections, completely lost. It's useless. Okay? So write it as a story, right? Take a creative writing course. Perhaps, I don't know, didn't do that ever. But, make it a pleasure to read to a degree, so that people will actually read it. Yeah, I said that. So, but now there's the problem, Papier ist geduldig, or bubbles don't crash, right? You can write down anything. There was not going to be some kind of compiler or test case you can write against whatever you said in the document, and it'll fail because you created something inconsistent. So writing things down as a thinking tool is helpful, but I think it's not enough. You have to build what I call the domain implementation. You take some environment where you can create prototypes of domain behavior extremely quickly. If you're good at TypeScript, you can do it as a browser-only application. There was once, a few years ago, something called naked objects, which was basically a programming environment where you didn't have to deal with GUI aspects at all, and it was very quick to prototype things. I'm sure if there's a small talk person that will tell me that's the way to go. I usually use MPS and implement the domain as an actual domain-specific language. Even if the goal of the project is not to build a DSL and we'll throw away the MPS stuff at the end of the project, I use it as a pocket calculator to formally implement the abstractions and make them runnable. This has proven to me the most valuable tool in understanding a domain. And I give you this example of this laser welding project where we spend a couple of months understanding the domain, building a complete executable language prototype thing in MPS. You can fully specify these welding instructions, and they would type check, and they would even run in a kind of simulator. And we found lots and lots and lots of kind of conceptual inconsistencies because we had a formal representation of the analysis results. And because MPS is so fast to build stuff, at least for people who know it, like I could spend the morning in the workshop understanding the domain, and in the afternoon I implement it in MPS, make it runnable. Next morning I turn the laptop around and say, hey, try it out. Is this the way you want to describe it? Works great. And then in the last couple of weeks, for whatever reasons, we stopped doing that. And now everything is just blurry. Frustrating, right? So build some executable prototype of the language where all the domain abstractions are formally captured in exactly the way you've decided. Make it runnable, and do it in a way where you don't have to implement 5,000 microservices and a build chain and an infrastructure and all this ility stuff, because it's too slow. And I honestly, some people always criticize this, well, but you should be agile and do feature by feature and stuff. I don't think this is the right perspective here, because incrementality is to some degree at odds with finding abstractions that cover a whole domain. Obviously, you run your analysis, your domain analysis iteratively. But just saying, okay, I just understood we need to support X, so I add X to my system. Takes me a sprint, 2 weeks, because of all the database stuff. And then, after 2 weeks, we notice in the next sprint we also need Y. So you spend another half sprint implementing Y. And then another 2 weeks later, you mean, oh shit, there is a common abstraction between X and Y and this other thing, Z, that we just found. You tear everything down. Sure, you can do that, and some people say, agile, you make mistakes, you learn, you do this, fine. If I do it this way, I can do all of this within a day. Right? So there is a point in using prototyping environments, even though some people would argue with today's technology stack, you're already relatively fast in building things. And again, I enjoy using MPS for that, but if you have other options to do that, great. And again, then you let your users play with that executable domain model, if you will, and help find inconsistencies, and that will also help when they play to kind of get everybody back to the same understanding, because they just ran it, right? They have this thing they can actually play with or experiment with. And as you continue, you build more and more serious things, right? You go from toy model cranes to real ones to try to implement a whole tax calculation of the, income tax in German. Right, which is, 500 rules, right? So it's more than this Hello World prototype you used in your validation session. You do something real. Okay, there's a bunch of additional things you want to be good at if you're playing that role of this kind of domain analyst. One is giving great demos, because you have to sell what you did, because you have to get buy-in from people who aren't your analysis team members. You have to be able to write well, so skill up there a little bit, and is good way or is useful to be good at receiving feedback and dealing with feedback and giving feedback on feedback. All right, wrap up. I told you about how I think you should go ahead in a domain. You should collect information, think about it, validate it with something executable. And then you, of course, keep in mind that there are other things that affect all of this. You have to align with business and strategy, with there's certain aspects of marketing. I don't mean external marketing. I mean marketing your analysis results to the rest of the organization. There is some intersection with agility and roles, like what does a Scrum Master do in this context, for example, right? And there is this whole thing about it doesn't help if you build a nice representation of your domain, but your business processes are completely at odds. Right? You change roles because now you have formal ways of modeling things, but you still have the same organization. Hard. That's also, by the way, where these projects fail. They don't fail technically. They fail because they get conflicted with politics. All right. Out of time. For some magic reason, I'm also exactly now out of slides. So we don't have time for questions. I was told it's uncommon to do questions at the end of this. Why is this moving forward? you can always contact me afterwards, or even better, get the book. And it's cheap for you guys. All right. Thank you.